Okay, we'll see if you remember from yesterday. This is the unit circle. A unit circle has a radius of 1. Without looking at your sheet, who could tell me what that location is? 1, 0. What is this location? 0, 1. This location? Negative 1, 0. This location? It is extremely helpful for us to know the location of many of these other spots. For example, if you have a 30-degree angle here, what would be this coordinate, that location? Or pi over 6 radians, what is that location? Suppose you had 45 degrees. What is that location for pi over 4 radians? And finally, for this spot, 60 degrees, what is the location for pi over 3 radians? What is that coordinate that matches with this piece right here, the 1, 0? I'll be interesting because you see that the x value goes from 1 and it goes back to 0 here. So these x values must be less than 1, but they also must be bigger than 0. Same thing for the y values. The y values start to get bigger, but the largest that they could be is 1. So what are they? And that's the piece that we're looking at today. This is going to require you to look back at a little bit of geometry. Are you ready to do that? Okay. This is the side we try to work through today. We need to remind ourselves of some special triangles. If you remember by the work we did yesterday, there's many angles that come up that use 30 degrees, 45 degrees, and 60 degrees. And this will bring us back to the good old times where we did right triangles. That had unique angle measurements. 30 degrees, 60 degrees, and 90 degrees. Do you remember, I'm not asking that you remember the relationship, but do you at least remember your geometry teacher saying 30, 60, 90? Okay. That's important. There's something special about a 30, 60, 90 triangle, okay? 45, 45, 90. That's another special triangle. And finally, 60, 30, 90, which is the same thing as your 30, 60, 90, just the bigger angle sits at the bottom. A 30, 60, 90 triangle comes from, it comes from a larger triangle. It comes from a 60, 60 triangle. The fact is that when you get a 30, 60, 90, it's just taking the 60, 60, 60 and cutting it right in half. Do you see that? Well, here's what's interesting about a 60, 60, 60 triangle. Suppose that this had a length of 10. This side had a length of 10. Then for a 60, 60, 60, all the sides have a length of 10, correct? But we're going to cut that in half. So if we cut it in half, does this hypotenuse length change? Does that change? No, it's still 10. Does this change? What is it now? It's 5. You see that? We cut it in half. It became 5. If this is 5 and this is 10, what could we use to find out this length right here? What formula do you know? The Pythagorean Theorem. And if we did the Pythagorean Theorem, which is sometimes a little bit of work, we would come up with exactly 5 roots of 3. And so it works out that the shortest leg is always half the hypotenuse. And that the longer leg, you just take the short leg and multiply it by the root of 3. That's it. Pretty easy, huh? So I'll put down a couple other numbers. Suppose instead of 10, suppose this has a length of 8. What would this side be? 4. And what do you do to this side to get this side? You multiply by? Not too bad, huh? Suppose I do one more. Suppose I make this side here 7. What would this length be over here? 14. What would this length be here? 7 roots of 3. That's it. See, geometry wasn't too bad, right? Anybody here, like, you loved geometry, like you thought it was great? Okay. Anybody love algebra 2? You thought it was great? Raise your hand if you liked geometry more than algebra 2. Raise your hand if you liked algebra 2 more than geometry. Okay, so some hands went up. So people have a nasty taste in mouth generally for geometry. My daughter, she's taking geometry right now. She says the same thing. She says, Dad, some of my friends, they don't like geometry. They only like algebra. So don't worry. It's pretty normal. Let's look at the next one. 45, 45, 90. A 45, 45, 90 is an isosceles right triangle. That means that those two sides are the same. Isosceles means that two sides of the triangle are the same. So we're going to try this one here, and we're going to start off with a length of 6. Suppose that this has a length of 6. What is the length here? 6. Is everybody convinced there? What could I then do to find this length? What could I use? Pythagorean theorem. Instead of using Pythagorean theorem, let's just trust that instead of multiplying by the square root of 3, we multiply by the square root of? Anybody remember? 2. Try another one. Suppose this length was 5. What would this length be? 5. What would this length be? 5 roots of 2. Uh-oh, watch me go. I'm going to do a different way. Suppose that this had a length of 3 roots of 2. What would this length be? 3. And what would this length be? 3. Now, I need you to lean in once more because I'm going to make this difficult now. 8. To go from here to here, you multiply by the root of 2, right? So to go from here to here, you divide by the root of 2. So this length would be 8 divided by the root of 2. Can you leave it like that? How do you simplify 8 over the root of 2? Multiply top and bottom by root of 2. And you get 8 roots of 2 over 2, or 4 roots of 2. That's what this ends up being. A little bit more work, huh? If that's 4 roots of 2, what's this? 4 roots of 2. Okay. 30, 60, 90 triangle. Again, it's just half of a 60, 60 triangle. So suppose that this had a length of 14. Do you remember what the length of the shortest side will be? 7. And what do I do to get the longer side? Multiply by root of 3. Hopefully that's a nice little review of what you learned in geometry, your relationship between your 30, 60, 90 and 45, 45, 90 triangles. This will now allow us to find the terminal points on the unit circle for the determined angle value of t. So what the heck does all that mean? We're going to walk you through together, and it's going to be no big deal. But trust me, this will be the most complicated thing I feel you've learned yet in this class. You're going to have to lean in, and we're going to have to practice. This is not simply, you will just get this. You'll just climb the mountain, you'll be done. You're going to have to work through some confusion here. We start with figuring out the angle. Pi over 4 is how many degrees? 45 degrees. Is everybody okay with that? So I am going to draw the triangle or draw the angle at 45 degrees. My goal when it says find the terminal points is to find that coordinate. I want to find that x, y coordinate. Okay? Is everybody okay with that? So what I'm going to do is I'm going to make myself a triangle. I will drop a side of a triangle down to the x-axis. You always drop it to the x-axis, never to the y-axis, always the x-axis. Which special triangle up here have I created? 45, 45, 90. Now, the nice thing is about the unit circle is what is the length of the radius all the time in the unit circle? It's 1. So you know that this length is 1. Is everybody okay with that? Now, I have to figure out how to go from this length to this side. In order to go from this side to the hypotenuse, I multiplied by the square root of 2. So to go from here to here, I divide by the square root of 2. So this side is 1 divided by the square root of 2. Can I have a square root in the denominator? No. So what do? Multiply by square root of 2. And we get root of 2 over 2. So that's this length. What is then this length? Root of 2 over 2. It's the same thing. Okay with that? So the question is, what is the x-coordinate? What is the y-coordinate? The x-coordinate is the length that I go in this direction, which is root of 2 over 2. And the y-coordinate is this direction, root of 2 over 2. That's my coordinate. Now, right now, you're going to wonder why in the heck do you have to know that? It is essential for us as we continue to learn the basics of trigonometry. You don't have to flip back, but I'm going to. Here's what we just discovered, folks, that this coordinate right here, you know that that one is 1, 0. This one is the root of 2 over 2 and root of 2 over 2. That's what we learned. That coordinate happens right there. We can figure out all of these coordinates. In class, we're just going to do 3 more, and then you're going to start to work through your assignment. You have to be able to do this for the test. Everybody will pass in front of me at this desk showing me that they know how to do this. It is essential, and you all will be able to do it. I have never had a student who was not able to work through this with me. I've had many students who tried to fake that they knew how to do it, but when we actually sat down and did it, everybody was able to do it, and you guys will be able to as well. We move along. 4 pi over 3. What is the degree measure? 240. Suppose that you are not like Isaac and you have no idea how he came up with 240. Here's what you do. You multiply by 180 over pi. What happens to the pi's? They cancel. What is 180 divided by 3? 60 times 4, 240 degrees. So the first skill is you have to be able to come up with the angle. I'm going to sketch an angle of 240 degrees. Which quadrant is 240 degrees? First, second, third, or fourth? Third quadrant, okay? And it's going to look about like that, right? That's about 240 degrees. This is 180. This is 270. Everybody agree that's about 240? So so this is the coordinate. This is my whole goal, everybody, right there. I want to come up with x and y. I want to come up with x and y. That's what I want to figure out. What do? You always draw the height of the rectangle or height of the triangle back to the x-axis. Always draw it back to the x-axis. What is the length of the radius in the unit circle all the time? 1. How does the shortest side compare to this side? It's half. What's half of 1? 1/2. What do I do to the shortest side to get the other side? Square root of 3. So watch what I'm going to do. I'm going to take the square root of 3. I'm going to multiply it by 1/2. Or square root of 3 over 1 times 1/2 is the square root of 3 over 2. So I'm going to name this coordinate. How far do I go in the x direction? Close. Not 1/2, but negative 1/2. Negative 1 over 2. How far do I go in the y direction? Negative root of 3 over 2. That's your terminal point. What did I just do? I just did, whoops, I'm sorry. I just did this. I found for 240 degrees, that coordinate right there is negative 1/2, negative root of 3 over 2. That's what I just found out. Here's a hint to you, everybody. You're going to want to write these down. Your terminal points will always be some of these values. It will either be 0 or 1/2 or root of 2 over 2 or root of 3 over 2 or 1. Those are all the values that you will use for your terminal points. If you come up with something different, it's wrong. Did you have a question? Oh, so let's figure this one out together. This one's negative. It's not too bad. Negative 5 pi over 6, okay? And so I'm going to multiply by 180. I'm going to divide by pi. What happens to the pi's? They cancel. I'm going to start with 180 divided by 6 is 30. 30 times 5, so it's negative 150 degrees. If I go negative 150 degrees, how is that different than going 150 degrees? Opposite direction. So don't draw this, but 150 degrees would be like that, right? So negative 150 degrees would be like that. It's just the opposite direction. So what I'm trying to do right now is I'm trying to come up with this coordinate right here. I draw a side to the x-axis. Who can tell me if this is 150 degrees right here, What is this small little angle right here? 30. Because it has to add up to 180, right? Good. So I have a 30, 60, 90. Boy, I wish I knew the length of my radius. What's the length of the radius? It's always 1. How does the shortest side of a 30, 60, 90 compare to the longest side? It's half. Notice how I'm getting these values that sit right here? What do I do to this side to get that side? Multiply by, and I get the root of 3 over 2. So if I want to know that coordinate, how far do I go in the x direction? Negative root of 3 over 2. How far do I go in the y direction? And that's the terminal point. Are you ready for the easiest one of all? Negative pi over 2. Pi over 2 is what in degrees? 90. So negative pi over 2 will be negative 90. So instead of going to this spot, what I do is I go to that spot. Agreed? So this is where people get confused. Everybody agree I end up right there? I don't need to draw a triangle. We've already figured out what that spot is. What is that spot? 0, negative 1. If you end up on one of the axes, you don't have to draw a triangle. It's just for the ones where you don't end up on the axes, you have to draw the appropriate triangles. Okay? Hey guys, this isn't a one-day lesson. This is a 3-day lesson. So yesterday we learned more about the conversion degrees to radians. Today you got your really first introduction into these pieces. And we are going to go just a little bit further tomorrow. But tomorrow you want to be able to leave class saying, hey, I know how to do this, and I can do it well. Okay? That's what you want to be able to feel like. Okay? So, excellent. I'll give you your assignment. You can start practicing some of these on your own.